Hello student, I am Dadapires from Government Degree College, Chanigiri. Today in this session we are discussing some problem about the molecular physics of the statistical mechanics of related to a Davangere University physics paper 6th. Let us discuss some problems for the point of view of exam. It is also very important. So, you must be write down as this question is there, and sometimes first write down the questions, make it slow and give a pause to this video, and after you write you go your face, as your face you proceed further. So, let us be related to next questions. The J, that is the rotational number J is 0 to 1 absorption line in carbon monoxide occurs at a frequency of 1.153 into 10 to the power of 11 Hz. So, calculate the moment of inertia, bond length, the lowest energy level of the molecule corresponding to J is equal to 1. So, given AMU is there. So, AMU means atomic mass unit is equal to 1.66 into 10 to the power of minus 27 kg. So, here is the calculate the moment of inertia at first. Whenever the problem is given, you must go as their direction is given here. So, first calculate the moment of inertia, then bond length and then the frequency. So, for the J is equal to 1, then J plus 1 equal to 1. So, we know that in the previous, in this equation, nu is equal to, that is frequency equal to h by 4 pi square I J plus 1, means so I equal to h is 6.63 into the power of 34 4 pi square, and nu is the frequency is given. So, that is 1.15 into 10 to the power of 11. So, J is equal to 0. So, then J plus 1 means equal to 1. So, on this value and simplify, we get the value of 1.46 into 10 to the power of minus 6 kg meter per meter square. At first, we calculate the moment of inertia. As we move further, let us calculate for the bond length. There is the bond length. Before bond length, that is R equal to mu R square. So, I equal to mu R square. Hence, first we found the reduced mass. The reduced mass is given by the relation m1 into m2 by m1 plus m2. Put this atomic number carbon monoxide. You must know that carbon is of atomic mass is 12 and oxygen is 16 into their atomic number, their number. So, put this value of oxygen here. So, oxygen is 16 and carbon is 12. So, then 16 plus 12 into their atomic mass unit. So, convert this atomic mass is into the kg, that is 1.6 into 10 to the power of 27. So, at last you get the value of reduced mass is 1.14 into 14 into 10 to the power of minus 26 kg is the reduced mass of the carbon monoxide. So, to calculate the bond length, that is I equal to mu R square, that is R is equal to square root of I mu, that is given by I is 1.46 in 10 to the power of minus 46 divided by 1.14, mu is 1.14 in 10 to the power of 26, its value given the bond length is 1.14 into 10 to the power of minus 10 meter. So, for the calculation of energy, so that calculate the energy for J equal to 1 means energy formula can be given by J is equal to Ej equal to Ej into J plus 1 H cross square by 2I, and for J is equal to 1 Ej J into J plus 1 after H is value is H by 2 pi, this value is H by 2 pi. So, and this value can be put this value h square by 4 pi square I will be given. So, after putting the value J equal to 1, H value, I value, and we got the after equating this value. So, Ej equal to 7.61 into 10 to the power of minus 23 joule, and this will be multiplied and divided by the E value, that is 1.602 into 10 to the power of 19. So, and this can be converted into EV. The energy is 4.76 into 10 to the power of minus 6, because E is equal to 1.6 into 10 to the power of minus 23. Put this value, divide this value 7.61, you got the 4.76 in EV. Let us go for the second one. Find the energy and angular velocity of carbon monoxide molecule in the ground state. Given carbon monoxide bond length is 0.111 nanometer and the mass of atom equal to MC equal to 1.199 into 10 to the power of 26 kg, and mass of oxygen is 1.9 into 10 to the power of 26 kg. So, on this for calculate the molecules, find the energy in ground state. For the ground state, we know that for ground state J is equal to 0. So, Ej equal to no dot, for J equal to 0, Ej value, that is J into J plus 1 into H cross square by 2I, that means J is equal to 0, Ej is equal to 0 for the ground state. Since the energy is given by the E equal to half I omega square is equal to 0. See here, but for the ground state, we know that angular velocity omega is equal to 0. So, hence the energy is also be equal to 0. So, there is no value, because for ground state the rotational number is also 0. So, hence angular velocity is also 0. So, this gives the value is angular velocity is 0 and also the energy is also 0. This is for second one. For the next third question, the force constant of carbon monoxide bond is 187 Newton per meter. Find the frequency of vibrations of the molecule and spacing between the vibration level. So, mass of the carbon dioxide is given, carbon 12 is given, that is 1.99 into 10 to the power of minus 26 kg into, and oxygen is 2.66 into 10 to the power of 26 kg. Let us we calculate for reduced mass, then we found the frequency of the vibrations. At first we calculate the reduced mass here. So, reduced mass is given by the m1 into m2 by m1 plus m2. So, put this value is m1. So, mass of the 1.99 into 10 to the power of 26 and carbon is 2.66 into 10 to the power of 26, and the sum is equal to mu reduced mass is 1.14 into 10 to the power of 26 sorry, 10 to the power of 26, and the frequency can be calculated for the vibrational, that is nu naught is equal to 1 by 2 pi square root of k by mu. K is the force constant here. So, you got the nu naught is equal to 1 by 2 pi is equal into the constant is 187 and the mu is 1.4. You got the frequency is 2.04 into 10 to the power of 13 Hz. So then calculate the separation between the vibrational energy level in carbon monoxide can be calculated, as we know that the change in energy, that is h nu equal to e to the power of mu 1 plus ev. So the difference between their consecutive numbers, that is gives to h u naught. H is the value is there 6.63 into 10 to the power of 34, and nu naught is 2.4 as we calculated here. So put this value and multiply, we got the value of 1.3 to 10 to the power of 20, and this value is joule. So and divided by E value, that is 1.6 into 10 to the power of 19. This value is divided by 1. Means this value is divided by 1.6 into 10 to the power of minus 19. You got this 8.44 into 10 to the power of minus 2 EV. So for the fourth one, for a diatomic, next fourth one is, let's see, for a diatomic molecule the reduced mass is 1.14 in 10 to the power of 26 kg, and the force constant of the bond is 167.8 Newton per meter square. Determine the spacing between the vibrational energy level in EV. So for the diatomic molecules, reduced mass is given. So mu is given here and constant is given here. So put this value in the equation, that is del u is equal to h nu naught, and h equal to nu naught value is 1 by 2 pi square root of k by mu. Put this value in this equation, that is h value is delta I h 6.63 into 10 to the power of minus 13 into nu naught. Nu naught is into 1.2 pi square root of k value is 167.8 Newton per meter square, and the mu value is that is reduced mass is 1.14 into 10 to the power of 26. So you got the value in 1.28 into 10 to the power of 19 joule. For the convert into EV, just divide this equation divided by 1.6 into 10 to the power of minus 19 to convert EV, so electronic volt. So divided by this charge 1.6 into 10 to the power of, you got the 0.08 EV. So this is the answer for the spacing of the spacing in carbon monoxide. So for the related next one, so in an experiment in the study of Raman effect, so using mercury given radiations of wavelength, the wavelength is given here for green radiations. The Stokes lines of wavelength 554.3 nanometer was observed. Find the Raman shift and wavelength corresponding to anti-Stokes line. So find their wavelength corresponding to anti-Stokes line. So here given is the wavelength lambda for green, that is 546.1 nanometer. So and this frequency can be calculated using the relation nu equal to c by lambda. Nu is equal to c by lambda, that is c value, as we know that 3.3 into 10 to the power of 8 meter per second, but don't go to put here because sometimes it cancel here, that's why keep it is as it is. That is lambda value is 546 into 0.91 meter, and this value nu is equal to, that is c into 18312 into 10 to the power of 2 per seconds. C value don't go to put here. So you got the value, simplify there. So for the wavelength Stokes line, the lambda 1 is given by 554.3 nanometer, and the frequency is can be calculated using this relation. Nu 1 is equal to c by lambda 1, that is c is keep it as it is, divided by lambda 1 by 554.3 nanometer, that is c into 18041 into 10 to the power of 2 per seconds. And this frequency, the Raman shift, that is the equal to nu equal to minus nu 1. So 18312 c into 10 to the power of minus 2 into c into 18043 their Raman shipment, the difference in their frequencies, that is 813 into 10 to the power of 10 meters second. This is Raman shift 813. The earlier one and this green one Stokes length, that is difference is the Raman shift. So 813 into 10 to the power of this is the frequency, and frequency of the anti-Stokes line, that is anti-Stokes line, the frequency can be add up. Hence the frequency of anti-Stokes line can be add, that is nu equal to plus c into 10 to the power of 2 into 271, that is Raman shift is there. So can you add this one, you got this value c into 10 to the power of 2 into 10 to the power of 2 into 18583. Keeping this value new one, the find the wavelength of anti-Stokes, usually as usual as in the above problem, that is lambda 2 equal to c by v, that's value is c by c into 10 to the power of 2 into c into 10 to the power of 2 into 18583. So after c get cancel here, so value is 538 nanometer. This is the wavelength of anti-Stokes line. This is about the wavelength of the this Raman shift. The how can we calculated in the Raman effect, Stokes line and anti-Stokes line. Anti-Stokes lines, they have more frequency, whereas Stokes line, they have a less frequency. So this about the problems related to the molecular physics, and work more some more problems in this way, you can be understand very well. Okay, thank you very much.